This podcast is sponsored by Home Performance Mastery, my series of online courses to teach you the tricks of the trade so you can stop guessing. More at homeperformance.training. Enjoy. Welcome to the Building Performance Podcast from Green Dream Group in Chicago. I'm Corbett Lunsford, and today we're talking about trends in high-performance building and retrofits with my friend Kristof Irwin, who is the founder and owner at Positive Energy in Austin, Texas. Kristof, thank you so much for being on the show.
Thank you for having me, Corbett.
So tell me what exactly your company does in Texas.
Well, like most of us have been in industry for a while, we've done lots of different things. We started as a rating company and evolved over the years. I'd say right now we are a building science consulting company. We do high-performance HVAC design, envelope design, and a lot of uh-oh inspections for builders that have had something go south in one of their projects.
Awesome. So he's a building performance hero, and also, just a side note, in case you ever meet him, he is, number one, incredibly handsome, which is unusual in the construction industry, and number two, he kite surfs, which is both incredibly dangerous and incredibly thrilling. So he's got that kind of air of mystery adventure about him. So, Mr. Adventure, what are the big adventures or problems that you're seeing in the actual work that you do on a day-to-day basis?
Very good question. I would say one of them that's on my mind a lot right now is energy efficiency metrics, specifically SEER, S-E-E-R, Seasonal Energy Efficiency Ratio.
That's for air conditioners, right?
That's for air conditioners, yeah. And so I think you should know air conditioners work, they're a machine, they have a role, they do something. They deliver comfort to a house, hopefully. And if we think about another machine like a car, what does a car do? Cars drive around, they go up and down hills. They have engines, and when we get the power out of the engine or the capacity out of the engine in a car, we use the accelerator pedal. So we have an accelerator. We give it more gas when we go uphill. We give it less gas when we go downhill. So that would be, if we were an air conditioning system on a very hot afternoon, we could give it a little more gas, give the air conditioner a little more gas. Mild afternoon, we give it a little less gas. However, the majority of the air conditioning equipment that's installed today in my house right now is fixed capacity. So let's pretend we're driving around our air conditioner like it's a car. So you get in your car, and it's off, and you're sitting in the parking space, and you better hope you're aiming for the road, because when you turn that key, you're floored, full speed, going fast as the engine can get you.
I love this story. What happens next?
So, well, then you have a choice, right? You're going 80, 90, 110. It depends, you're on the interstate. And you're like, well, I'm going a little fast. Well, I better ease up on the gas. Well, there is no ease up on the gas. There's just turn the key off, right? You turn the key, now you're going to get rear-ended. So you have a choice. You can give it a little more gas. Turn the key back on. There's no little more gas. You floored and off you're going again. So this is how air conditioners go, right? So I hope my father's not listening, but there's something called neutral dropping, where you put your car in neutral and you give it gas and then you drop it into drive and spin wheels, and that's wear and tear on the transmission, wear and tear on the engine. It wears out. Similarly, on a mechanical equipment side, you jam it from stop to start over and over and over, it wears out. Not only does it wear out, it's a horrible thing to do for energy efficiency. And I guess most sad about the whole thing is that comfort is destroyed in the process, right? It's too hot, and then it goes to too cold, and then too hot and too cold.
Is it more sad that it's dumb? I find that more sad, that it's just a dumb way to do things.
Yeah, so it's a tool, right? An air conditioning system, let's even step back once. So a house is a functional device, right? It delivers performance. It delivers comfort, indoor air quality, the stuff that you and I all know very well. Energy efficiency being one of them, durability. And so in that functional role, we should think about, okay, well, there's basically two components. There's the fixed components, the building envelope, and then there's the mechanical components, and they work together to deliver its functional role. So building envelope, we just said it's relatively fixed, and my God, we could talk for days about building envelopes and the proliferation of new product systems and technologies there. Really exciting stuff. And as I just mentioned to you a minute ago, most builders get that. So we have this relatively fixed physical object sitting where? In weather. What is weather? It changes. It changes gradually and incrementally and continuously throughout the day, right? In Austin, Texas in the summer, which is when most of my clients are really nervous about making sure their clients are comfortable, it's going to be 110 in the afternoon, but it doesn't start out at 110 in the afternoon. So it starts out, and interestingly, nighttime lows in Austin when it's crazy hot in the afternoon, nighttime lows are in the mid 70s. So nighttime lows are actually below most thermostat set points. So you wake up in the morning, you don't need much capacity, and then gradually the sun comes up, the east wind, if your house isn't shaded, it'll hit you coming through your windows. You need a little capacity, and then the sun comes up, it gets hotter. Now you have radiant load and conductive load through the envelope. So your air conditioner should be coming on a little more. What if you had two systems inside, indoor units, one that could serve the east side and one that could serve the west side, or the day zone and the night zone, both connected to one outdoor unit? You could have the outdoor unit serving the east zone in the morning, and then the west zone in the afternoon. But the point is that the temperature and therefore the load on the building is gradually changing throughout the day. But the equipment is typically set up to come on and come off, come on and come off. You only get those two choices like we talked about a minute ago. So there is a type of equipment called VRF equipment that
Which stands for?
Variable refrigerant flow. We'll talk a little bit about the technology in a minute, but it's mature technology. I mean, it's 25, 30-year-old technology that most of the rest of the world has adopted for various reasons. We, for some reason, are just slow to adopt it. There are builders and architects that are still nervous about it. There are tens of thousands, if not hundreds of thousands, of buildings in this country, and many thousands of homes that have VRF in there. And it's a better tool, right? So you have this variable, continuously changing load, and with VRF you have the ability to do variable, continuously delivered capacity that would change. It's intended to run all the time. Longer run cycles is going to enhance dehumidification. There's a lot to say about it. Like anything, the more you learn about it, like they say, the larger the continent of knowledge, the longer the shoreline of mystery, right? So the more we learn about anything, the more you feel humble. So VRF, variable refrigerant flow technology, as I said, it's a mature technology. It's been around for a long time. It's based on two things. So that accelerator pedal, it's two things create the accelerator pedal. One is a compressor that instead of being tied to the 60 hertz power, which is all around us in this room, right? You turn that lamp on, it's at 60 hertz. That's 60 cycles a second. AC's voltage is going between plus and minus 120 volts, 60 times a second. So if you think about, liken that to pedaling a bike. I'm pumping my bike along at 60 hertz, 60 cycles a second with my legs. Well, most bikes that we ride nowadays have a back wheel that's not tied to what your legs are doing, right? You have gears on the bike. So VRF technology uses an inverter compressor to be able to vary the compressor speed from 60 hertz up and down, right? So Mitsubishi, it's 15 to 115. Daikin has like 50 to 200. They have different, but there's a range of compressor speeds. So let's use Mitsubishi, which is on the order of 15 to 115, right? It's morning, you have barely any load in your house. It's going to come on at 15 hertz. It's also going to come on at 2 to 3 amps instead of 80 to 100 amps and then go down to 40. It's going to come on at 2 to 3, go up to the most of 25. I rarely measure them at 25. Usually 2 to 3 amps. They're running at 2 to 3 amps. So it comes on, 15 hertz. Let's say 4 in the afternoon, you're in Austin, Texas, and lo and behold, it's a crazy hot winter day and you're having your friends over for a Super Bowl party and you have 40 friends in the house. It's going to crank up to 115 hertz and it's going to give you peak capacity, right? And then they all leave and they go home and it's still a little bit warm and it's going to scale back down. It's going to go continuously up and down throughout the day, tracking the loads in the house with the delivered capacity of the equipment.
Now, this is different, and it's really important that people understand, correct, that it's different than a variable speed fan.
Oh, yeah, definitely. So when you hear the word variable, you should prick your ears up, and if you hear speed fan, yeah, you want that, of course. You should want that. That should be a given that you're going to have a variable speed fan at this point in our market evolution. But variable, you want to hear the words variable capacity equipment on the back end. We all know of a crude, I'll use the word crude version of variable capacity, which is dual stage equipment and unloaders, right? So in the scenario I said about the car, it could go on and off. Well, a two-stage machine could go on, half on, and off, right? So it's better. You don't only have an accelerator, but you got this middle speed. And an unloader, it would be on, 2/3 on and off. So that is considered, the sort of the pinnacle right now. You have builders that say, oh, yeah, I use two-stage equipment. Right? Well,
And we'll run all the time on the low, just in case we ever need the high, right?
oh, yeah.
I love that one.
Yeah. And, you got to understand that the builders, they want, like all of us, they want to be protected from risk. And they're making the best decisions.
All of us except you.
Yeah.
The kite surfer.
I like to kite surf. Yeah. If anyone's listening to this and wants to learn to kite surf, be very, very careful. Treat it very seriously, like you're learning to fly a Cessna or something. Think about it like that. It's not a trivial sport to learn.
Awesome. So to get back to your earlier thing, so variable capacity equipment is what we're looking for. And a big part of the reason was what you initially got into, which is SEER, which is seasonal energy efficiency ratio, right? And it's seasonal because air conditioner only runs in the summertime.
Well, yeah, there's reasons behind it. Mm-hmm.
So what is the problem with this metric?
So SEER, say you have a 16 SEER system, it's rated at one metric. It's rated at one set of load conditions, and you get the capacity at those load conditions. So I think a lot of us understand already that set of load conditions is probably not representative of what's they're encountering in their climate zone, but nonetheless, it is a peak capacity load rating, right? So how does a single stage equipment work at part load conditions, which by definition are the vast majority of the hours of the year are part load conditions? So there's no metric to compare single load condition to part load conditions. Right?
And therefore a single stage piece of equipment that only runs at 100%, comparing that to variable capacity. Is that what you're saying? They would have the same SEER?
They could have the same SEER. In fact, so let's see. So there's something called IEER, Integrated EAR. And so SEER, I said, was rated at one set of load conditions, which is peak capacity. Let's call that 100% load condition. So IEER would include that full load condition. They would have to tell you, what is my EER, which is just a non-seasonal. It's just, EER is simple. It's just BTUs of cooling or BTUs of heating divided by watts of energy. Right? So,
and also to clarify, load in this kind of context means the amount of heating or cooling that you need to deliver into a building to equalize the temperature.
Correct.
Okay.
Exactly. Like load of firewood in a pickup truck, or exactly. You said it exactly right, Corbett. So IEER would have the efficiency at full load, at 75% of full load, at 50% of full load, and at 25% of full load, and would give you a weighted average of those. And it's a defined metric that's been around for quite a long time. And the reason I guess I'm on a little bit of a soapbox around it is because if you use SEER, which is what most of the marketplace understands, to rate variable capacity equipment, it might or might not rate efficiently, right? So in the VRF realm, there are some wall units that are one-to-one wall units that are up as high as 30 SEER now. But it's not very easy to get traction with that in the marketplace. Instead, ducted units. There's vertical upflows. There's these little compact. They're like there's units that are like a stack of 4 pizza boxes stacked up, and the air blows in one end and out the other. And it's a variable capacity head, and you can put full house duct system on it. So those pieces of equipment, when you compare them using SEER, they don't look so good. They're like 15.5 SEER, 16 SEER, and a Carrier 18 SEER or a Train XL20i, they'd be much higher SEER ratings. However, you're totally missing the point because you don't get part load performance out of fixed capacity equipment. One other thing, I actually didn't quite finish the how does the VRF work? So how it works is you have this variable frequency compressor, and you match that to a linear expansion valve, also sometimes referred to as an electronic expansion valve, to deliver precise refrigerant metering that is microprocessor controlled to be working with the circuit controlling the condenser, the compressor, which is in the condenser.
For those of you who might be lost at this point, Kristof is referring to just sending less coolant through the lines so that
Right.
it reaches the coil where it's actually going to cool the air.
Yes, thank you.
That's
So,
for the dummies in the room, me. Just like I translate that in my head.
okay, so here's one for that I like to use a metaphor on. So, a refrigerant metering device is a lot like a hose spigot, right? So it sits on the side of the house and it's off and you can turn it on. But imagine that I would say to you, Corbett, could you give me 1/2000th of on, please, on that spigot, right? So there's full off, there's full on, and then I went, oh, give me 3/2000ths. No, give me 7, give me 14, and I can change that number
So demanding.
thousands of times. I don't know how the exact frequency, but definitely more than once a second. So you're constantly adjusting refrigerant, matching it to the compressor's speed, and constantly adjusting throughout the day. This equipment stays on long periods of time. Because it's inverter technology, it uses, let's just take a 4-ton. I happen to know the numbers for that one. A 4-ton outdoor unit is going to pull, like I said, it's going to start like 2 to 3 amps. It has a peak of 20 amps, but it's going to operate in the, let's say, 2 to 5 amp range all day long. So it comes on 2 to 3, has a peak of 25, goes 2 to 5. That's the outdoor unit. Let's compare that to a normal the conventional outdoor unit. Comes on 80 to 100 amps, settles down to 30 to 50 amps. So, and amps scales with power. So you can see there's a big savings on the outdoor unit. Go to the indoor unit. Indoor unit at my house is something like 8 amps. It's a 3-ton unit. A 4-ton VRF unit is going to pull like 1 amp. Right? So if someone comes to a builder or an architect and says, I'm interested in some sort of near net zero performance or net zero performance, and VRF equipment is not brought up at that design meeting, boy, oh boy, there's a very real chance that somewhere down the road that client might find out about VRF and call the architect or builder and say, excuse me, there was a page on the menu you didn't tell me I could shop from. And that's a real risk, right? And so, I'm fortunate that I have a lot of very good builders and architects that work with me that know about it. And I guess I'm a little bit evangelical almost about it. Like, people should know about
That's
this.
good. You got to be evangelical
So
about
thank you
something.
for helping me
Yeah, absolutely.
tell people about this.
Awesome. Kristof, thank you so much for being on the show.
Thank you very much, Corbett. I appreciate your time.
Kristof Irwin is the founder and owner of Positive Energy in Austin, Texas. You've been listening to the Building Performance Podcast from Green Dream Group in Chicago. I'm Corbett Lunsford. Tune in next time.